I use my simple grid for good enough.
Okay.
All right. Yeah, I should not have told anybody my free covering. Yeah. Yeah. He didn't use simple grid. That's
So we have looked at 5 measures of center: mean, median, mode, trimmed mean, weighted mean. Just to sort of summarize the advantages and disadvantages of each, and then we'll do a couple of examples. So we really talked about all of this, so we can go through it fairly quickly. The big thing about the mean, it's useful for describing the center if there are no outliers. Okay. And remember, outliers are extremely high or extremely low values. And so it kind of follows that a big disadvantage of the mean would be not very useful if there are outliers. Right? For the median, useful for describing typical center. The main reason for that is it's resistant to outliers. Meaning outliers won't affect the median very much. Okay. And probably the biggest disadvantage of the median is it's time consuming to find. Like if you're finding a median house price of like 20 houses in a neighborhood, I mean, you have to list them all from smallest to largest. So you have to list all those 6 and 7 digit numbers from smallest to largest, and then figure out the middle, and then average the two. So it's pretty time consuming. Whereas mean, all you have to do is just add them all together and divide by how many there are. For mode, well,
easy to find.
Easy to find, definitely. Okay. And it's also resistant to outliers unless the mode is one of the outliers. Okay. And really, it's more useful for what's called nominal data. And nominal data are non-numbers. So it'd be words. So things like baby names. You can't use the mean and median to find the typical baby name, but you can use the mode. It's the one that most people use. Okay? Election votes. You count the names. The one with the most names wins. Okay? So that's where the mode is a little better. And the big disadvantage of the mode is that it could be very far from the middle. Or from the center of data. Which is why when it comes to numbers, if the data are represented by numbers, mode's not great. Okay? Okay, first example we're going to look at, and we'll just talk about this. Okay, we're not actually going to do any calculating. So one hospital did a study to determine the typical age of patients that are hospitalized by 2 different viruses. For virus 1, the median age of patients was 30 years old. For virus 2, the median age of patients was 70 years old. So for virus 1, does the median of 30 necessarily mean that most adults around the age of 30 had the virus? Not necessarily. How could it, what's another way that could give us a median of around 30?
If that was just younger.
And then we had a large group below and a large group above? Yes, exactly. Okay, so there's 2 ways you could have the median. You could have a big grouping around 30 and then some above, some below. Or you could have big groupings there and little in the middle, and it would still work out to 30. Okay, so no. You could have a lot of young and old ages. And few around 30 in the middle. Or few around 30. When you see for the second virus, the median is 70, what are you thinking? Is it though? If the median's around 70. Like, what does that tell us about the virus?
Or less common, sorry.
That what?
Less common?
Well, no, who does it likely affect?
Yeah.
If it's a median 70?
Oh, sorry, no, it's the older.
Yes, right? So clearly, there must be a lot of high numbers. Okay? So in this case, we would have to say it affects older people. Because you can't have that, you can't have a grouping of around 30 years old and then a grouping around 110 years old, because there's just not that big a group around 110 years old. Okay? What else could we represent besides the median to show maybe a better measure of center?
Mean?
Mean or the mode? Definitely the mean. Okay? Okay, this example here, we've got a list of annual incomes, and I'm not going to go through the whole process of calculating mean and median. I'm just going to give you the numbers because you guys should know how to do it. Okay. So what would we, just tell me what we would do for the median. Like, how would you find the median here?
5 and 6, the number and 2,
Okay, what do I have to do with all the numbers?
order.
Right, I have to go smallest to largest. And because there's 1, 2, 3, 4, 5, 6, 7, 8, okay, there's 2 in the middle, and I average them. Good. So I'm assuming you guys know how to do that, so I'm just going to tell you that the median is 26,500. And the second question is actually the definition of the median. The median is a number so that half of the data values are below and half are above. If you look, how many of these are below the median? 1, 2, 3, 4. How many are above? 1, 2, 3, 4, which gives us a good measure of center. Okay? So 4 above, 4 below. And that's the very definition of the median, so that you have half your stuff above and half your stuff below. How about the mode? Should be able to pick that out. 20,000. And again, how many salaries are less than the mode? How many are greater? Well,
There's none left.
there's none less. And there's 1, 2, 3, 4, 5 greater. None less, 5 greater. Definitely not a good measure of center. It's definitely tilted. And finally, the mean, you guys know how to calculate the mean, add it all up and divide by 2. So I'm just going to give it to you. It's 31,000. And then we're going to do the same thing again. And then this time, if you count it, 5 more, 3 less. Not the greatest measure of center, not terribly far off.
Wait, isn't it the other way around?
Oh, sorry, 5 less. X, thank you. 5 less, 3 more. And what caused that? There's an outlier in that data. Okay. What's the outlier?
15,000.
Yeah. Okay. And so we kind of answered the final question now by saying that the mode and mean weren't great, but the median was quite good. So it would just be median. Now, the other 2 measures of center we did were related to mean, the trimmed mean and the weighted mean. So advantages of the trimmed mean. Okay. It's useful for, and the statistical word we use is skewed data. And by that, I mean high or low values. Because we trim them away when we have that skewed data, stuff above, stuff below. And therefore, because we're getting rid of the outliers, it's resistant to outliers. So therefore, it is a reasonable measure of sense. Better than the mean, than just the mean when there's outliers. Okay? Can you see where the trimmed mean wouldn't be good?
If there's a lot of values.
Almost. What kind of values? No,
There's a lot of.
if there's a lot of outliers. Because we may not be able to trim all of them away. Because remember we said like trim 5% above, trim 5% below? Well, if there's a lot above and below, we're not going to get rid of some. And it's no longer going to be resistant. So not great if there are a lot of outliers. And finally, the weighted mean. Remember, that's when we have categories and data values in categories. Okay. So what's an advantage of the weighted mean? Well,
I guess it could be more visual.
what's that?
Visual, because you put it in a video.
Yes. So using a table, good visual. It's good when data represents multiple people in multiple groups. Like we did that one with salaries of restaurant employees. And what was it? There were like 2 hosts and 9 servers and I don't know, 3 managers or 3 working in the kitchen or something like that. So instead of adding all those individual ones up, I could just say, okay, 9 times whatever the server salary is, 2 times whatever the host salary is. Okay. I'll leave it at that. And finally, the disadvantage of the weighted mean.
Wouldn't it be like time history?
Not necessarily more than the mean. It could be. If you have multiple categories, it could definitely be time consuming. So yeah, okay. Could be time consuming. It also can be misleading. If random weights are used for the categories. And that could be like a breakdown of marks. I mean, really, who decides the breakdown of marks? Well, the school or the teacher that teaches the course. That's not necessarily, what's the word I'm thinking of?
Reliable?
Yeah, there you go. Okay, because who's to say like, okay, a course where tests are worth 50, exam is worth 50, or tests are worth 80, exam is worth 20. Like what would you, like if I said, okay, There's your two choices for this course. Test 50-50, exam, test and exam 50-50, test 80, exam 20. Which-
Testing.
Right, because we do a lot more of that, right? That's the majority of the stuff we do for the year. If I said 50-50, that's a big weight for the exam that only happens just one day. Okay? So it's kind of arbitrary. That's the word I was thinking of. Okay, I'm not going to worry about this. Okay. Not going to worry about this one. And we'll just quickly look at this last one. Yeah, I think I might take out that example 3. I'm not really a big fan of it. So here we've got a table from a few years ago, represents the number of marriages and divorces in Canada by province and territory. And it also gives us the total in Canada. Okay? So the total percentage of divorces to marriages was almost 50%. And then we can see the breakdown by province. How could we calculate the mean and median? Well, we're not going to use this value because this is a separate thing. So for the mean, we're going to add all this up and divide by how many there are. Okay. And then for the median, we're going to list them smallest to largest and find the one in the middle, or 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13. That means there'd be one number in the middle. So I'm just going to give that to you. The mean, you add all those up and divide by how many there are, you get 42.7%. And the median, when you list them lowest to highest and find the one in the middle, you get 42.25%. So they're actually pretty close. Okay. Which is, well, how can I explain that? Like, my first reaction when I see that they're so close, I'm like, yeah, but Quebec, it's got a big percentage. Shouldn't you think that would make the mean higher? And we've got a couple that are fairly low, that will pull it back down to where it should be. Okay, good. You guys are looking at the record. So the outlier, if we took out the outlier, one could make the argument that there's more than one outlier, but we'll just take out the 75.12. And when we take out the 75.12, the mean becomes 40%, which kind of makes sense because now that we've taken out that high one, those ones that were pretty low kind of dragged it down a little bit below the median. And are these values 40% for a trimmed mean? 40% for a trimmed mean, 42.7% for a regular mean. Obviously, they are different than this, right? Quite a fair bit lower. So, no. And why do you think that is? Because what? Why do you think that is? Yeah, because we didn't do the weighted mean, did we? We just added up the percentages that we got. But clearly, more weight should be given to what provinces? The bigger ones, Ontario and Quebec, and British Columbia. Okay, more weight should be given to those than the other provinces that have less population. Okay, so that's really the reason, no. Because that 47.62% is the weighted mean. Which is actually a better measure than just adding the percentages and dividing by how many there are. Okay. Okay.